Hello, Honors Calculus. So, long time no see. We are back for this very strange, very sad last month of school. Um, and I know I'm struggling with motivation, and I am not a senior who is just having probably the worst end of a senior year I could think of. So, that being said, I'm sure it's even harder for you. I'm certain it is. But I still think I really do that next year you will be oh so grateful when you're in your college math courses if you can stick it out here and just at least like have some of these concepts make sense. So just really try and hang with me. I'm gonna stay totally reasonable on the workload. I hope, um, but I want you to learn some calculus. That's our goal. Learn some calculus. So that being said, I some of you filled out the survey before the break. If there's anything you want to tell me, um, just always be in touch. Let me know what I can do to improve things. But I know, or I was getting the vibe that some people were a little bit shaky about kind of when do I use what where for all these things we learned about in our online learning time, basically since I've taken over the class. So, based on what I'm seeing, it looks like most, if not all of you, are pretty comfortable taking derivatives right now. So, you might make mistakes here or there, but I think everybody has a sense of like, this is when I use the quotient rule, and this is when I use the product rule, and this is how I use the definitely power rule and some of the trig things. So, you seem to be doing really well there. If you don't feel confident or if you have questions, definitely let's go over it. Um, but as a group, you seem to be doing really well there. I think some of you have gotten all of the chapter 3 stuff with no issue. Some of you are feeling less confident. Either way, it's been 2 weeks since you've done calculus. So I thought let's just start this week with reviewing what we've done so far. And then I'm actually going to be skipping a few sections and moving into sort of an application of all of these things called optimization. So I said it was going to be guided notes, but actually I filled it all out for you this time around because I thought that was just a more efficient way this time. So there's a document up on Schoology which has all of this with steps put into it. And I made sure that I fit it on one page because this is where my teaching style is maybe gearing towards my learning style. So if this isn't you, I do apologize, but I like to have just like reference sheets. So if I were doing something where I'm applying differentiation, if you just sort of have as a document the thing that I made, if that's helpful to you in front of you, I think that will help you problem solving. So what I did is I went back through everything that I have taught you so far and tried to organize it in a way, again, that kind of works for me. And so here's what I come up with. Every single problem that you have solved since we've been online has been asking you essentially to use one of these 4 skills. Okay, so I mean, there were some where you're practicing tools just so you could find it, but this is really what it's all about. So it's about being able to find the maximum and minimum values of a function on either a closed or an open interval, being able to find the intervals over which a function is increasing or decreasing, and being able to find the intervals over which a function is concave upwards or concave downwards. So maximum and minimum values, I mean, I imagine now, especially with everything we're seeing in the news, and I keep emphasizing that, we're like living a calculus problem is what this is. But finding maximum and minimum values over open or closed intervals, I imagine you can figure out the applications of that. But as we practice problems, you'll see it more and more. Um, uh, this one, finding intervals over which a function is increasing or decreasing. Essentially, we're looking at slope, the derivative. Is it positive? If slope is positive, it's increasing. The function is increasing. Whenever slope is negative, it's decreasing. So we're finding those intervals over which that's happening. And then this one's a little different, finding if something is concave upwards or concave downwards. So this is just finding if the function itself is increasing or decreasing. This is finding if the slope of the function is increasing or decreasing. So when I originally taught it, I used motion because that's my world of physics. But also I think we can all picture that. If I gave you a function for something's position, the first derivative of that, just bear with me, but the first derivative is speed. Physically, that's what it is, speed. And then the second derivative is acceleration. So if I'm trying to find is my rate of motion increasing or decreasing, if the speed is increasing, first derivative, then the rate of motion is increasing. If the speed is decreasing, my rate of motion is slowing down, it's decreasing. Intervals over which it's concave up or concave down. So if the acceleration is positive, that means the speed itself is increasing. And if it's concave downwards, the speed itself, so the slope, is decreasing. So that's kind of, just as an example what those are. But again, we'll see it with a bunch of different practice problems. The big idea here are these are the 4 things you need to be able to do. So all the problems we do in sections 3.1 through 3.4 ask you to do 1 or more of these 4 things. Now the one thing is you see the word, when they're saying find maximum and minimum, they use the word extrema a lot for that. It means the same thing, right? So, okay, so then we learned about essentially 4 tools that we can use to do these things. Now there are 2 that I left off this list. They are on the document, just so we were really summarizing everything we learned. Those 2 are called Rolle's theorem and the mean value theorem. I left them off because they're important. Mean value theorem is used primarily just to prove things in our future. So I wanted you to see it. You will see it a lot in college calculus if you were to take that. But you can do every one of these problems without ever using it. And the same is true for Rolle's theorem. Rolle's theorem is used sort of as a proof of a place having a 0 derivative, but it's not necessarily useful for any of these 4 things. So I left them off. So the 4 tools you need to be comfortable with to solve problems are finding critical points. Critical points are places where the derivative of a function is 0 or if it's undefined. Using the first derivative test. The first derivative test, put simply, is finding a place where the derivative goes from positive to negative. That would be a maximum value for a function. Or finding places where the derivative goes from negative to positive. That would be a minimum value of a function. Just imagine a curve. Like as the slope changes, you would either have a max or a min. Finding points of inflection. Points of inflection are places where the second derivative is 0 or undefined. I haven't been writing that, but. And then using the second derivative test. The second derivative test takes critical points, so you still have to find those critical points with the first derivative. And if at a critical point the second derivative is less than 0, you have a maximum point. So it's kind of reverse of what you would think. And if a second derivative is greater than 0, you have a minimum point. So you can go back through the sections or the PowerPoints or the YouTube videos, whatever's useful for you, and revisit any of those tools if needed, where we go through it more. But those are the 4 things you need to be able to apply these skills. Now, you will see on the guided notes that I have for each of these things, like typed out the explicit steps that you need to solve the problem. Clearly, I don't have a lot of room on the board to do that. So you hopefully have that in front of you. So what I'm going to do is just kind of match up the tools you would use for each thing. But again, go to that document, and that's where I give you step by step. So if you think a problem is asking you to find an interval over which a function is decreasing or increasing, then go to that. You see the steps there, and that's what you use, okay? All right, so finding maximum or minimum values on a closed interval. The tool you need here is being able to find the critical points. Again, there's more to it than that, but that's the tool that you use to find the maximum and minimum values on a closed interval. Finding intervals over which a function is increasing and or decreasing. Again, you have to use those critical points to make intervals. So this is where you would use them. Finding maximum or minimum values on an open interval. Here you can use the first derivative test or it's just like up to you, the second derivative test. I'm running out of room, but so either one of those things. Now both of those things require you to use critical points. So you use critical points all over the place. And then finding intervals over which a function is concave upwards or concave downwards. This you need to be able to find the points of inflection, and then you use those points of inflection to come up with your intervals. So again, if we're taking these tools, so you just hopefully can find all these things. If you're taking those tools and applying them to what kinds of problems would I use them in, here we have it. So I am going to, in a second video, and probably third because there's a lot of problems, be working through some practice problems that review each of these types of problems, so using all these tools for these things. And so as I go through the problem, I will say like, oh, this is skill 2, finding intervals over which it's increasing or decreasing. And so you can kind of, again, have as a reference in front of you, okay, these are the steps I'm going to use then to do that problem. So you can watch me solve them and kind of solve along with me. So on the back of the document where I summarize everything, or second page of it, I have some practice problems. And if you feel like, again, you want to see some problems before you dive into it on your own, follow along with me and go through and watch those videos. If you're like, yeah, I got this, I was solid before the break, solid now, just jump right into the review assignment and you can go for it and refer back if needed. Or you might be a little bit in between, a little bit of both. So again, everybody is required to do the review assignment where you will be doing problems of all of these types. I tried to keep it reasonable, so I think there's like 7. That's it. But if you want to see, I know some of you indicated, and I will totally own that you are correct, that I have not been doing a whole lot of sample problems that are like mirroring the homework. So if that is more helpful for you, again, I'll continue to do this as we go through the course. But go watch the videos in which I solve the problems that are on the second page of this document. Okay?